Okay, this is day one of 9.8, factoring polynomials completely, and you're going to learn two new ways to factor a polynomial today. One day is factoring by grouping. Little do you know, you actually have already started doing this. You're going to create your own groups and factor out a common term from each of those groups. Hopefully you get a common binomial, what we like to call magic. Factoring completely means that you have factored out everything to the point where there is no possible way to divide anything in there completely or by the same number. And I'll kind of show you what we mean by that. I talked about it a little bit with 9-7. So what you're going to see are expressions like this. You have 3x times this factor of x plus 2. And you have minus 2 times, hey, that same factor, x plus 2. If you have 3x times this and minus 2 times that exactly the same thing, you can factor out that x plus 2. And what you're left with is 3x minus 2. Remember the step where the magic happens before we rewrite it? Here it is. So I rewrote my magic factor, and what was left is my other terms. So here I have y squared times y minus 4 plus 3, and this isn't y minus 4 exactly. If I try to put it where the y is first, you've got to remember, sorry, I want this up here. You've got to remember that that negative belongs to the y. This is actually negative y plus 4. That's not y minus 4. How do I turn this into y minus 4? Well, I use my y squared. I hate that I cannot type a squared. I'm sorry. I take my y squared. Frustration. I take my y squared. There we go. And now this is y minus 4. Now, to make this a positive y minus 4, change that 3 to a negative 3. And now you've got your y minus 4. And then I factor out my y minus 4. And what I'm left with is y squared minus 3. Oh, buddy. Minus 3. Now, yesterday, or in 9-7, we started talking about a difference of squares. This is y squared minus something. But this is squared and this is not. So I can't do my really cool, awesome trick that I learned in 9-7. This right here is your final answer. Y minus 4 times y squared minus 3. So if you're looking at expressions like this, this is the other way to do it. So the magic factor was already there in example 1. In example 2, I'm going to factor this expression. But do you notice that there's nothing I can divide everything by? But if I don't look at everything and I just look at these two, I can actually factor out a y squared from just those two. And then I'm left with y plus 7. And if I just look at these two, I can factor out a 2. So plus 2, and guess what I get? I get y plus 7. Hey, there's my magic factor again. So now I can have the final factored form of y plus 7 times y squared plus 2. And I can't factor that y squared plus 2 any further because it's not a subtraction problem and 2 isn't a perfect square. So take a look at that again. Let's change colors. So I can't divide everything. Like all three of these terms have a y, but this one doesn't. So I can't divide everything by that. But I can divide these two by a y. And I would be left with y plus 2. I'd be left with y plus 2. And out of these two, I can factor out, actually what I'd factor out is an x. But I would be left with y plus 2 again. And it should work out this way. And then what your two factors would be are that y plus 2 that's repeated, and what's left on the outsides that we factored out, which is a y plus an x. And that would be your final answer. Very cool. Now, if you're looking at these, x to the third minus 12 plus 3x minus 4x squared. I can factor something out of these two, but I can't factor anything out of that. So let's change the order, because addition is commutative, and I can change the order to be whatever I want it to be. Let's put the x to the third with the minus 4x squared. There's a reason why things are pretty in this order. So what we look to do is put the exponents in order. So let's put the 3x next, and then the minus 12. Now this is going to be much easier to group and factor. We put them in order based on their degree. The degree is the biggest, baddest exponent you have. That's a question on your test coming up. So I can factor out an x squared. That leaves me with an x minus 4. And out of here, I can factor out a 3. That leaves me with, hey, x minus 4. Woohoo! So I have my common factor of x minus 4. And then times my x squared plus 3. And my x squared is squared, but my 3 isn't, and it's an addition problem. All right, so this is your final answer. X minus 4 times x squared plus 3. So you might have to create your own groups to then factor it. So take a second, work out these checkpoint problems, and then come back and see if you got the right answer. So hit pause now. All right, how'd you do? On number 4, you would have needed to put them in order first to then be able to group them. So let's start talking about the other way. So here's the kind of thought process you should have when you are factoring. So that's what your whole chapter 9 test is. First thing I look to do is, can I divide something by all of it? Can you factor out the greatest common single term out of everything? Once I've said yes or no to that, I move on. Is this a difference of two squares where it's something squared minus something squared? Because that's an easy answer. Or is it a perfect square trinomial? Is this an a squared plus 2ab plus b squared? And if it is, just go straight to that perfect answer. Or factor the trinomial that's in that ax squared plus bx plus c form. This is the form that you guys keep getting stuck on, that you only want to do this. And then the last way, if it's got 4 terms, the only way you really can do it is by grouping. So to factor out this polynomial completely, it's a trinomial. So what I'm going to do, can I factor out something from all of that? These two have x's, but not that one. So no, I can't do any of that. Okay, so we've already ruled out that we can't divide it by everything. So now I look, is it in the nice pretty form of a squared plus 2ab plus b squared? Well, this is a squared term, and this is a squared term. So that would be x and 1. Oh, but that's not addition, so it's not really a squared term. Especially for the perfect square trinomial, because nothing times itself would be -1. So I've got to go to my next level. There is no number in front of the x squared, so I just need something that multiplies to be -1, but then something that adds to be +3. Think about that for a second. What multiplies to -1 but adds to +3? Nothing. Nothing. The only thing that multiplies to -1 is +1 times -1. That's it. So there are no numbers that will give you this. I know it's not factorable. If it asks you to factor it completely and it is not factorable, that's as far as we can get. If I can't even do that, that's it. So let's go to letter B. Remember, the first thing you should always look, can you divide something from all of those? Well, all of those numbers can be divided by 3, and all of them have an r. So I can actually factor out a 3r from each term. If I divide this by 3r, I'm left with r squared minus 7r plus 10. All right, well, now I've got this whole trinomial in here. I've got to do the process all over again. I can't divide everything by the same thing. And this is an a squared, but I don't have the b squared perfect square trinomial. So let's go to the next option. This is r squared with no number in front of it. So can I multiply something to get 10, but add to get -7? Well, yeah, -5 and -2. So this can actually be factored, remember your 3 are factored, into r minus 5 and r minus 2. So you need all 3 of these factors to have the correct answer. This answer literally is 3r times r minus 5 times r minus 2. You have all of it. All of it. Let's take a look at this last one. Now, looking at it, always start, can I pull out something from all of it? Always start with that. And you notice that both of these have d's? And they actually have enough for me to pull out d squared from each of them. I don't have a number that they have in common, so I just have 9d squared left. And then 4d squared divided by d squared would just leave me with 4. All right, let's start back at the beginning. I've factored out everything I can, and this is a binomial, so it'd be really cool if this was a squared problem minus a squared problem, which it is. And you've got to remember that the squared problems minus the squared problems become that weird addition subtraction problem. So this is 3d, minus 2 times 3d plus 2. And there are your factors. We have factored it completely. If you look at each term in here, there's nothing else that you can divide those by. That's it. Nothing else. You are done. All right. Your homework assignment over 610, 13 through 40. It is just these types of factoring where all you're doing is factoring, no solving today or on this one.